So the last thing I want to talk about in this video is about isotopes. And isotopes are basically different, I don't want to say different forms, but they're the same atom with a different mass number. And the best way I can illustrate that is, say we take a, let's take an element from the periodic table. Let's take number 10, which is neon, right? We got neon right here. And we're going to say that neon has a atomic number of 10, so with the 10 right here, and then a mass of 20.18. So if someone asks you, hey, how many neutrons does neon have? You know, you're going to follow the formula we did earlier, which is do 20.18, which is the atomic mass, subtract the atomic number, which is 10, and what do you get? You get 10.18 neutrons, right? And you're thinking, well, I did the math right, so what went wrong? This is what an isotope is. It is basically different atoms of neon, each having a different mass number. Now that mass number difference arises from having a different number of neutrons. So that's to say, for example, you have a neon with atomic number 10 over here, and that has a mass number of 20. That's it. But then you have a neon here, 10 protons, 10 electrons, atomic number 10, but your mass number might be 19. And then you might have another one here, and you have a 21. So basically, over here you have 10 neutrons, over here you have 9, over here you have 11. So the numbers on the periodic table that you have are an average of all these. So we're taking an atomic mass average. And that's what gives you the values on periodic table. And that is important to know, because sometimes they'll tell you, well, you're using carbon that weighs 12. This means carbon that weighs 12. Or they'll say the carbon that weighs 14. In both cases, your atomic number is the same. Your atomic number here is 6, and over here it's 6 as well. So the basic takeaway here is protons do not change. Your number of protons stays the same. If it's neon, neon's always going to have some protons, but the number of neutrons you have is up for grabs. So what I'm going to do now is do just a quick review of the periodic table. So before I start that, I'm just going to draw a quick little table right here. And that comes down and across. So the reason I'm doing this is I just want you guys to get a little familiar with, you know, how the table works and what it looks like, and, you know, things like that. So the table is actually, wow, I cannot draw a straight line for my life. So the table is broken up into columns and rows. So we have columns that go this way, and it goes all the way across. And then, you know, clearly we have the rows that go across like that. You know? So what we have is columns and rows. Now the columns, which go vertical, are called groups. Now this is group 1, group 2, and it ends with group 7 and 8. And the reason is that this little group in the middle is called transition metals. They kind of mess with the group numbers. But what you need to know basically is you have 1, 2, and then 3 starts here, 4, 5, 6. I didn't actually draw the rows, but I'll go ahead and draw them right now. And then, you know, we have 6 and 7 on top of each other, but let's just say 7 is a level up to here and 6 is over there. I hope that makes a little bit of sense. So that's how the groups go. The ones in the middle do have group numbers, but they're not really called by their group names. Generally speaking, if you have like lithium here, and then you have sodium here, potassium here, you would say a group 1 element concerning one of these. You wouldn't really say it for anything in the middle. So group 1 actually has a very special name, and that is alkali. They're called alkali metals, alkali earth metals. And group 2 is similar in that it's called alkaline metals. The way I remember it is kind of like alphabetical. Alkali comes before, so alkali is 1, alkaline is 2nd. They're called alkaline, alkali earth metals, if you want to be a little more specific. These are highly reactive metals, okay? Highly reactive. And then let's move on to further right. We're going to go this way in the periodic table. So we've got 1 and 2. Now we have this little space right here, right? This area. And this area is known as transition metals. I'll go over in later videos why it's called transition metals. For right now, I would just want you guys to get familiar with what the periodic table looks like and, you know, what's called what. So these are transition metals. And then moving further to the right, what we have over here is this very prominent staircase looking thing. It goes all the way down the periodic table. And what this does is actually divides the periodic table into nonmetals and metals. So we got this side, which is nonmetals. Alright? And this side is metals. That's important to know. Now, the space where the staircase, this is called a staircase by the way, the elements that the staircase touches are called metalloids. And the reason they're called that is because they have characteristics of metals and nonmetals alike. Okay? So moving further to the right, we're going to look at group 7. So let me go right here. So group 7. Group 7 is a very important group to know. It's called halogens. Okay? And then we have group 8. Also very important, called noble gases. So that's a basic overview of the periodic table. And like I said, this is just a very rough introduction to the concepts, like initial foundational concepts of chemistry. So in future videos, I'm going to go into a lot more detail and go through a lot more problems and a lot more topics. So definitely stick around for that, okay? I hope this helped and keep watching. Thanks.